Siddhant Varshne, are you there? Aryan Nigam?
Yes, I'm there. I'll just
Can
start.
you please read the problem?
Yes, sir, yes. The problem says a balanced three-phase AC supply with configuration 400 volt and 50 hertz feeds a 20 angle 53 degree ohm Y connected load. Find the following. And the note says the supply voltage is always specified in terms of the RMS magnitude of line voltage.
Okay.
And
Please.
it has 8 parts we have to answer: line voltage, phase current, line current, power factor, true power, reactive power, and apparent power.
Thank you, Aryan.
No problems.
Thank you. So the problem says that you have this, you can call it star connected or Y connected, as Aryan says. Both of the notations are accepted. So you have a okay. So this is the configuration of the load. The load is Y connected or star connected, and per phase impedance is given. Per phase impedance is given. Now Aryan, please mind, and all of the students also, please mind this fact that this will not be always stated in the problem. This has to be taken for granted. The paper setter assumes that as soon as he writes three-phase AC supply, 400 volt 50 hertz, the student with background in engineering should understand that this is the line voltage. Okay, unless and until mentioned otherwise. Okay, this is the line voltage. So what is the value of line voltage? Tell me. Any answers? Directly we can say it is 400 volts. Okay. Since the load is star connected, what is phase voltage? Tell me. Since the load is star connected, what will be the phase voltage?
By root 3.
Very good. The phase voltage will be 400 upon root 3. You tell me what is the value of 400 upon root 3?
230.94. 230.94.
Okay. Load is star connected. This is very important point. Now, one thing you should please note, a golden principle which you should understand very and apply as soon as possible. Now in this problem you are lucky enough, the paper setter, the question setter has specified what he wants, 1 2 3 4 5 6 7 8. But generally when as an engineer, you are given a problem statement. The problem is just written. Okay. And then you have to make out of it what are the sub parts of the problem. This is one very important concept in coding which my teacher taught me and I still remember. Okay, he told me when you have a code, first when you have to write a code to solve a problem, first of all break the problem into sub problems. And I still remember he taught it with the example of writing the code for writing a spiral of a matrix. You know what is the spiral of a matrix? Anyone?
No, sir.
Anyway, leave it. You can the problem he taught in that way. He taught us write down a code for writing the printing a matrix in its spiral form. Anyway, leave it. You can learn it anywhere. It's not our subject. But the problem is, point I am mentioning over here is that you should write down all the different subparts of the problem, and you are very lucky in that sense that the question setter has given it. Okay. So first part is already connected. Line voltage we have found out. Line voltage is 400 volts. Phase voltage is line voltage upon root 3 since load is star configured. So what is 400 upon root 3? It will be nearly 231. Is that correct?
Yes, sir.
Yes, sir.
Okay. So it will be approximately 231 volts. Now they are also asking what is phase current. Phase current means current flowing in any branch of the circuit. What is, if you call it A, if you call it B, if you call it C, what is IA? What is IA? What is IB? What is IC? Okay. IA, IB, IC, their magnitude, that is called phase current. We have already discussed these terminology. Okay. So it is equal to phase voltage upon per phase impedance. Okay. What is phase voltage? And per phase impedance we have already found out it is 20 angle 53 degree. What is the magnitude of the, tell me, what is the magnitude of phase current?
11.54. 11.54.
Yeah. 11.55 I guess, or 11.5. Okay, approximately. And line current
Equal.
will be equal to phase current. It will be equal to same. Okay, what else they are asking? Power factor. Power factor you can directly compute from the given impedance. Impedance is what? 20 angle 53 degree. So it will be cos 53 degree. Since the load is inductive, it will be 0.6 lagging. Okay. How I am saying it's lagging, because I have seen in self-assessment test some of you were unable to differentiate between lagging and leading. How I am saying that it is lagging load? Tell me.
Sir, its value is positive.
Yeah, you can see that this is resistance, this is reactance. Reactance value is positive. It means what? If it is positive, the current will be V upon Z. The current phase angle will be negative. Okay. So current will lag the voltage. For positive value of reactance, current will lag the voltage, and that's why we say lagging. Okay. What about real power? Real power P is equal to, you can either say 3 Vp Ip cos phi, or you can write root 3 VL IL cos phi. Similarly, reactive power, this will be in watts. Reactive power, 3 Vp Ip sin phi volt ampere reactive.
सर एक बार लीडिंग लैगिंग वाला एक बार फिर से बताना कैसे डिसाइड करा?
देखिए, वोल्टेज को हम रेफरेंस फेजर लेते हैं, राइट?
यस सर.
ओके. And current Ip is equal to Vp upon Z. Okay. So Vp, let us say we have taken 231 angle 0 degree. Z is what? 20 angle 53 degree. This is in volts, this is in ohms. So it will be 11.55 minus 53 degree ampere. Now if you see current
Yes
lag.
sir, got it sir.
Okay. Current lags. Okay. So this will be in volt ampere. Now tell me the value of it. Do the computation. I am giving you 3 minutes for 3 computations and tell me the answer. In fact, you post your answers. P is equal to this, Q is equal to this, S is equal to this in the chat box. I'm going to the chat box now to see who is posting. Okay, some people are really fast. Amritanshu has posted. Let us check. We will wait up to 250. Very good. Initially, when I saw one answer, I was a bit skeptic, but now it's correct. Most of the answers are correct. But dear, uh, Amritanshu, why you have written a negative sign over here, dear, for reactive power? Are you there?
Sine of minus 53 degree.
Mm-hmm. I will just tell you, you have to understand this concept a little more. The absolute answer is correct, but the sign I am little bit skeptic about it. Depends upon which convention you have chosen. Okay. I will also tell you the general convention. So the answers, I am seeing only Amritanshu's answer and Aryan Nigam. Other students, I don't know what problem they are facing at their end, but you have to raise the flag. Then only I will get to know what is your response. Okay, Harshvardhan also has posted his answer. Adarsh Aditya, but is still out of Ayushman Saxena Good. Out of 64 students, only a handful of students have posted their answer on the chat box, which is very heartbreaking for a teacher. Anyway, I will continue because we have dearth of time. Okay. So the correct answer is, as most of you got it correctly, for real power it will be nearly 4800 watts or 4.8 kilowatt. Reactive power it will be nearly 6400 volt ampere reactive or 6.4 kVAR, the short form which is generally used, and apparent power is 8000 volt amperes VA. Okay, so let me write it down. So this answer will be approximately 4.8 kilowatt. This will be 6.4 kVAR and this will be 8 kVA. Okay, now Amritanshu has raised a very nice thread. He has initiated a very nice thread. In the chat box he has written minus. Now we need to understand what is this. Now please understand this phi is the angle of the per phase impedance. Generally Z is mentioned as mod Z angle phi. Now if you see in this problem, phi is 53 degree, but you might be confused when you write Vp is equal to 231 angle 0 degree, Ip is equal to 11.55 angle minus 53 degree ampere. When you pick up this as the value of phi, you will be tempted to write sine phi as minus sine phi. Okay. But if you pick up the value of phi from the per phase impedance, you will be writing positive. If you pick up the value of phi as this, you will be writing negative. Now, I am not saying I am right or I am wrong or you are right or you are wrong. It depends upon the convention. But the convention which we have been following till now is this mod z angle phi. Is that okay? So from that convention it is plus, and this convention, again to remind you, this is the passive sign convention. Passive sign convention, if you remember, an element is supposed to exhibit positive power when it is taking power. Okay, okay, when it is taking power, and it is supposed to have negative power when it is giving power. Now if you see this point, an inductive load, it consumes reactive power. Very important thing, very very important. I told you when I was teaching you about charging and discharging, and I think I need to reiterate this. An inductor is the sink for reactive power. A capacitor is the source for reactive power. Okay, this you have to keep in mind. Therefore, if you follow the passive sign convention, which we have been following, reactive power or Q positive for inductive load and Q is negative for capacitive load. When I say, not I, it's not about you or me, it's about the principle. When we say inductive load, it means what? It means omega L impact is not far greater than, is greater than omega C. And capacitive load omega L less than 1 upon omega C. Now please the problem. Question. Now, can somebody read the problem? That will ensure the readability of the problem for everyone. Can somebody read the problem once?
Yes,
Oh,
a
please.
44 angle minus 37 degree ohm delta connected three-phase load is fed from a 440 volt 50 hertz three-phase AC supply. Compute load
Please read the full
voltage.
form. Yeah, very good. VL. Line
Load
voltage.
volt.
No, no,
Line
no.
volt.
Line
Sorry, sorry,
voltage.
sorry. Yeah,
No,
yeah.
no. You need not be sorry. It's my mistake. I should not have. I have used.
No, sir, it's not your. It's my mistake. I should have
It's
said line voltage.
it's line
Uh,
voltage. Okay.
line
Yeah.
voltage, phase current, line current,
Yes.
uh, power. Oh,
Real
sorry,
power.
sorry. Real power,
Real power.
reactive power, and
Very,
apparent power, and power factor.
very good. Thank you very much. Now, please, you do not have more than 5 minutes to solve this problem. Please. Again, my expectation from you now is that you post your answers in the chat box.
Okay, I think we should start the meeting. We are having only 5-10 minutes. So I request all others to please join us and please post a message on the group. Okay. So this is regarding the parking app and connection of experiment. So the rate here is 10 is 15 should be there. Are you want to say?
So you have time 3 minutes more. Please post your answers.
इम्पोर्टेंट चीजें मैं उन्हीं में अगली बार डिस्कस करूंगा कुछ चीजें हैं जो मैं डिस्कस कर लेता हूं एक तो मेरी किसी फोन का वीडियो आपके बारे में एक यूट्यूब से जो है रिजेंबल सिलेबस से और माइक्रोलॉजी वो आपको डालना है तो इंग्लिश में कंफर्टेबल कौन सा आपको अच्छा लगा हाँ कोई बताएगा अगर कुछ फीडबैक अगर आप बोलते और मैंने यूट्यूब पे यूट्यूब वाले अच्छे लगे आपको ज़्यादा अंडरस्टैंडिंग उसकी हो रही है तो ठीक
कार्तिक के शर्मा राहुल को गलती से डाला हो हाँ आपने डाला है कार्तिक के शर्मा आपने लिया कार्तिक के शर्मा और राहुल को लिया आपने हाँ दे दो आ जाना एक बार
Okay, I'm seeing some more answers now. Okay. Harshvardhan, are you there? Are you there, Harshvardhan? Are you able
Yes,
to hear me?
yes, yes,
हाँ
yes,
बेटे, एक्चुअली क्वेश्चन में अगर आप देखो ना तो क्वेश्चन जो हमने दिया है ना वो 440 वोल्ट है। ये कॉन्सेप्ट आपने सही लगाया है ना?
yes, sir.
कॉन्सेप्ट सही लगाया है। लाइन वोल्टेज विल बी इक्वल टू फेज वोल्टेज फॉर अ डेल्टा कनेक्टेड लोड, बट again if you read the question, the value of line voltage is 440 volt. Okay, I think this question is easy. You can solve it on your own. You can solve. I am expecting that those who are hearing my voice should post the answer on the chat box. I don't think I need to discuss the solution for it. It's because it's a very simple question. Okay, there is nothing tough in this. Okay. Okay. Now, what I will be discussing, I will be discussing a very important concept, which is very important from problem point of view. Like we were discussing the 2 watt meter configuration, and we discussed why we use 2 watt meters, why not 3 watt meters. So I have a question for you, that if you use 3 watt meters in place of 2 watt meters, what will happen? What will happen? If I use 3 watt meters in place of 2 watt meters, is it wrong? Somebody will like to comment on that? Never mind, just take an attempt. Right or wrong, we are not interested in that. Only 1 minute for commenting. You just have to unmute and say something that will be accepted as a comment. Do not worry. Okay, nobody seems to be giving it a thought, so never mind. So what we will do, we will analyze it ourselves. What you are seeing here, this envelope, this surface, you can say, it is encapsulating a balanced three-phase load. Let us assume that it is a star connected load. Then what will be the value of VAB, IA, IB, VCB? Can you tell me?
Root 3 times the source voltage.
If you take it as a star connected load, duplicate it. Let me duplicate it. Okay. If you assume that it is a star connected load, okay, what will be the reading of W1 and what will be the reading of W2? Can you tell me what will be the reading of W1 and what will be the reading of W2? Okay, you can just shortly write if VAN is equal to VP angle 0 degree, VBN VP angle minus 120 degree, VCN is VP angle minus 240 degree, and it is Z angle phi star. Then W1 is reading VAB and IA. So clearly VAB will be what? It will be root 3 VP angle plus 30 degree. Okay. And what will be IA? IA will be IP angle minus phi. Okay. Similarly, what will be the reading of W2? If VAB is this, you can quickly write VAB. We already have derived this, that's why I'm directly invoking these answers. It will be VL angle plus 30 degree. VBC will be VL angle minus 90 degree, and VCA will be VL minus 210 degree. Okay. So if you see, the reading on wattmeter 2 will be VCB. What will be VCB? VBC is VL angle minus 90 degree. So VCB will be VL plus 90 degree. Okay. Or you can write it root 3 VP plus 90 degree. Okay. And what about IC? What about IC? IA is IP angle minus phi. IB is IP and IC is IP minus 240 degree minus phi. Okay, these two things are our takeaways. IC is IP the readings on wattmeter 2, readings on wattmeter 1. Is that clear why I have written like this? So if you see, the reading on wattmeter 1 will be VL or root 3 VP. Okay. Okay. And what is the current IA? It is IP angle minus phi. What about W2? It is root 3 VP angle plus 90 degree, and current is IP minus 240 degree minus phi. So what will be the reading? You know, wattmeter reads what? Wattmeter reading is voltage magnitude multiplied by current magnitude and cosine of angle between them. Okay. So tell me, what will be the reading of W1? Magnitude is root 3 VP, voltage magnitude, current magnitude is IP, and angle between them is 30 degree plus phi. Similarly, reading of W2 will be root 3 VP IP cos 30 degree minus phi. Is that okay?
Yes, sir.
Is that okay? Understandable? Now W1 is very easy to understand, but how I wrote this requires a little jugglery of angles in the argand plane or the phasor plane. Then you will be able to see that W1 is this, W2 is this. Any doubts in this? Any doubts in this? Tell me.
No, sir.
Don't have no doubt. Clear.
Yes, sir. What's in this slide is clear.
Okay. So do something as your homework. Find out W2 plus W1 and find out W2 minus W1. Okay, and tell me a tentative date, not tentative date, a solid date. Okay, when you will be writing your quiz 2. So let me stop now. Okay, thank you very much. I need to leave. Please excuse me. Who will take the responsibility? Who I can see from the class committee? I can see Sayam. I can see Parth from among the class committee. Are you there? Sayam Jain, Parth. From among the class committee, I can see only two people on directly. No.
Yes, sir. I am also here.
Okay, you are also here, Nilanshu. How to please give me a proper date and time for quiz for the next quiz. That will be counted. Okay, and the syllabus will be same as for the midterm 2. Okay, please let me know. Okay.
Okay, sir. Sure, sir.